Hello again. Today we're going to discuss basic things related to support conditions for rigid bodies in 3 dimensions. And the first thing that I would like everybody to remember is that when we deal with equilibrium of rigid bodies in 3 dimensions, we will apply the exact same principles as we did for rigid bodies in 2 dimensions. And this means that firstly, we have to always draw a free body diagram of the body that has to be analyzed. Now, in 3 dimensions, this can be a little more challenging, and therefore we have two main options. The first option is to draw a 3-dimensional pictorial view of the body that we want to analyze, with all the forces and dimensions shown on this 3-dimensional pictorial. Now, this sometimes can be challenging to do, and therefore we have another option in which we can draw a set of orthogonal projections of the 3-dimensional body, which means we would reduce the 3D body to a series of 2-dimensional free body diagrams in each of the 3 orthogonal planes, and that would be the XY, the YZ, and the ZX planes. Now, once we have done that, we have to again look at and decide what to do with the various supports that restrict the movement of the rigid body and help the rigid body achieve equilibrium. So when we deal with a constraint action on the body, again, the main principle is that we will have to follow the same principles that we use for 2-dimensional rigid bodies. So in other words, what we've done before and what we're going to do now is to use the principle of action and reaction. And when we do so, we have to remember that when removing a support, we will always replace that support with forces or moments that are corresponding to every degree of freedom that is prevented by the support that was removed. So this is very important. This is what we need to remember. We replace the support with forces and moments that correspond to the degrees of freedom, to the movements that are prevented by the support. So we always have to look at the support and see what is not allowed, what is prevented. If there's a translation, we replace the translation with a force. If it's a rotation that is not allowed, we replace the rotation with a moment. Now, let's look at a few types of support conditions for rigid bodies in 3 dimensions. And before we start doing so, I would like to point out that there's a table in the textbook which is more complete, more comprehensive, that you should refer to and you should always use in solving problems and also when you write tests. You would have to have the table in mind. Now, I'm going to do this in a table in which I will actually compare the types of supports and what it prevents, so what it has to be replaced with, for a case in 2 dimensions that we're already familiar with, and with a case in 3 dimensions. So let's start first with a member in contact with a smooth surface, or sometimes in 3 dimensions, a member supported on a ball. Now, this is a kind of a roller situation in 2 dimensions, so we will replace that support with one normal force. And the same thing would happen in 3D. We will replace with one normal force, but now the normal force in 3 dimensions will be, of course, oriented in the space with 3 dimensions. It will have three components in the general case x, y, and z. Now, a member in contact with a rough surface, it's similar as before, but now we also have friction force. So in addition to the normal force, we have one tangential force as well. In 3 dimensions, the same thing, but now we are in the 3-dimensional space. The third case is a general roller or wheel support, which, as you know, in 2 dimensions, a roller would prevent translation in one direction, which is normal to the surface on which the roller acts. The same thing would happen in 3 dimensions. However, sometimes we might have a roller restricted laterally. So then in addition to the normal force, we would also have one lateral force corresponding to the lateral movement that may be restricted in that case. Now, another type of support is a pin, or in 3 dimensions is often called a ball and socket support. So in 2 dimensions, a pin was restricting translations in 2 directions. A ball and socket support in 3 dimensions will now restrict translations in the 3 directions, the 3 orthogonal directions, x, y, and z. So hence, a ball and socket support is replaced by these 3 forces. Finally, the last example that I would like to give is the fixed support, or also sometimes called a built-in joint. So a fixed support in 2 dimensions does not allow translations in x and y, as well as moments in z. It's the most general case in 3 dimensions, as this type of support would not allow anything. So no translation, no rotations in any of the 3 axes. So you replace this with 3 forces along x, y, and z, and 3 moments around x, y, and z. So again, please review the table in the book as well. And thank you very much for watching this lecture. And I will see you at the next one.